All right, guys, go ahead and open your notes to page 29, I believe is the page we're looking at today. So on page 29, Ms. Tversky, we already took notes on this. I know, but there's a reason we need to go back through this because we've been looking a lot at perfect squares, but I want to talk to you guys about perfect cubes. So on your test that's coming up here before spring break, you need to have the following numbers memorized. You need to have the first 12 perfect squares memorized. So 1, 4, 9, 16, and all these perfect. So 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. 3 times 3 times 3, 27. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. 6 times 6 times 6 is 216. 7 times 7 times 7. 8 times 8 times 8. 9 times 9 times 9. 10 times 10 times 10. 11 times 11, 11. 12, 12, 12. Okay, so if you have these on your sheet, go ahead and pause the screen and take these down. Make sure you have them nearby because it's going to make your day a lot easier if you write all these down. So, back to our notes. Over here, we already went over this, but I want to show you a few things. Okay, so perfect cubes are going to be the same things as perfect squares in a sense, but instead of multiplying the number twice, we're multiplying it 3 times because we're taking a number or a base and raising it to the third power. So 3 times 3 times 3 gives me 27. If I scroll down here, okay, actually I like this idea here. If I look at this, we've learned that I can take a square root of a number and find its side, right? I can also square a number and find the area of that object if it's a square. Same thing for cubes. As long as it's a cube, which means it's a square, okay, but with 1, 2, 3, 4, 5, 6 sides, right? So to find the volume of something, it's length times width times height. Let me show you a shortcut. So yes, if you have all these perfect cubes memorized, your life will be a lot easier. But say you're not sure 100% if 27 is a perfect square, or sorry, perfect cube. All you need to do is take 27 and say, okay, well, what are 3 numbers I can multiply together to get 27? Yes, we know the answer is going to be 3 inches. But what if I need to show my work for that? I could say 3 times 3 times 3 is 27. Do you remember for perfect squares how we had 2 buddy pairs go outside the house to play? Well, now we're going to do the same thing, but groups of 3 since it's cubed root. So we have one group of 3 that goes outside the house to play. So my answer is just going to be 3. What about this 30 centimeters? Let's work on this one, 30 centimeters cubed. Well, let's break down 30. 2 numbers that can multiply together to get 30. Okay, it's going to be 6 and 5. Get 2 and 3. Do we have any buddy pairs in there? No, we don't. So the cubed root of 30 times the cubed root of 30 times the cubed root of 30 is going to be 30. So leave that cubed root of 30. Okay, what about this one with 125? Well, yeah, we know it's going to be 5, but let's try the math. Okay, 125 breaks down to 25 and 5. This breaks down to 5 and 5. So I have a group of 5 that goes out to play. No one left in the house. What about 100 feet cubed? Well, let's try. I've got 3, 100. This will break down to 10 and 10. Okay, so nothing else can come out of that. We don't have 3s of anything. So this is just going to be the cubed root of 100. All right, go ahead and scroll down. So let's go ahead and try. We know the cubed root of 125 is 5. We've answered that. The cubed root of 343 is going to be 7. Let's go ahead and try number 12. For perfect squares, we talked about how we can break these up into 2 separate little houses, if you want to call them that, for cubed roots. So I know the cubed root of 1 is just going to be 1 because 1 times 1 times 1 is 1. Well, the cubed root of 216, if you look back at your notes, 216 is a perfect cube. The cubed root of 216 is a perfect cube. It is 6. So what you're going to do is put 6 on the bottom. I want you to go ahead and try 13 and 14 on your own. Go ahead and do that for me. Pause your screen. When you're done, I'll go over the answers. Okay, so if I have cubed root 1 over cubed root 1000, Cube root 1 is 1. Cube root of 1,000 is 10. Down here, the cubed root of 8 is 2. Cubed root of 125 is 5. And let's take a look down here at 17 and 18. If I have 32, I know this is not a perfect cube, so I need to go ahead and break this down to try and figure out if I can simplify the cubed root of 32 at all. So 16, we know, will break down to 4 and 4. This 4 is 2 and 2, 2 and 2. So as I mentioned before, when we are simplifying square roots, we're trying to find buddies to send outside to play outside of the house. Now, since we're doing cubed root, we're trying to get groups of 3. So I have one group of 3 that goes outside to play, and I have leftover 2 and 2, so 2 times 2 is 4. I have 4 inside the house, but remember this is cubed roots, so I need to put that little 3 there. So 3 multiplied by the cubed root of 4 is my final answer for that one. What about if I have 135? Well, 135, the cubed root of that, is not a perfect square. So 135 divided by 5 is 27. And you might recall that 27 is a perfect cube, right? 27 can be broken down to 3, 3, and 3. So 3 times 3 is 9, 9 times 3 is 27. Here is a group of 3 that's going outside the house to play. I have my cubed root sign with a 5 inside the house. All right, let's go ahead and scroll on down. So what I want for you to try, okay, on your own is going to be the problems down here that we have not filled out yet. When you are done with this, I'm going to have you come show them to Ms. Swiderski and conference with me. Again, same thing as simplifying squares, but we're trying to find groups of 3.